The Jonas Brothers have been to the year 3000, but have you ever solved problem number 3000 on LeetCode, maximum area of longest diagonal rectangle? We're given a 2D array with the length and the width of different rectangles, and we want to return the area of the rectangle with the longest diagonal. Or if there's multiple rectangles with the longest diagonal, then we want to return the one with the maximum area. So let's take a look at the first example. We're given the length and the width of two rectangles, and to find the diagonal, we're going to use the Pythagorean theorem. So for the first one, 9 squared is 81, and 3 squared is 9. So 81 plus 9 is 90, and the diagonal would be the square root of 90. For the second rectangle, 8 squared plus 6 squared is 100, and the square root of 100 is 10. So the second rectangle has a larger diagonal. So we'll return the area of this rectangle, which is 8 times 6, or 48. And you may have noticed, since we're just trying to find the rectangle with the largest diagonal, we don't actually have to do the square root when we do a squared plus b squared, because whichever one has the largest c squared, when we take the square root, is also going to be the largest c. So we don't actually have to do the square root. And for this problem, it's really straightforward. There's no tricks. We're just going to loop through the array and find the rectangle with the maximum diagonal and keep track of that maximum diagonal in the area of that rectangle. So let's write the code. First, we're going to create some variables to keep track of our max diagonal and max area, which we're going to initialize to 0. And then we're going to iterate through each rectangle, getting the length and the width of each one, and calculate the diagonal as length squared plus width squared. And remember, we don't really have to do the square root of the diagonal. And inside the loop, we're going to check if the current diagonal is greater than the maximum diagonal we've seen so far. And if it is, then we'll set the new maximum diagonal to the current diagonal, and we'll also set the maximum area to the length times the width of this rectangle. Otherwise, if the current diagonal is equal to the largest diagonal that we've seen so far, then we don't have to set max diagonal because it's the same as it already was, but we may have to set the maximum area if the area of the current rectangle is greater than the area of the rectangle with the largest diagonal, even if they had the same diagonal. So we'll set max area is equal to the max of the max area we've seen so far, or length times width of the current rectangle. And once we've looped through all the rectangles in the array, we just return the max area, and that's it, we've solved the problem. Now the time complexity of our solution is linear, or O of n, where n is the number of rectangles in the array, because we loop through the array one time. And the space complexity of our solution is constant, or O of 1, because we're keeping track of a constant number of variables, which is just the maximum diagonal and the maximum area. That's all for today, and if you made it to the end, don't forget to like and follow for more.